Right, let's check on the parabola scenarios. Then we'll try to do some other simple examples where possible. Right, on the parabola, of course, we know the highest exponent is going to be to the power minus to the power 2 as the highest exponent. So this is a format of a parabola. Now, in this format, we have the value of a. We know this is an equation with y equals to ax squared plus q. I'll elaborate on q. Now, basically, in lower grades, you know that normally when say parabola is y equals to a x squared, meaning that the a will just give us the shape and how wide is the graph. So in that grade, meaning a being greater than 0, then we take the shape of looking up like this, which is saying smile. Then if the value of a is negative, then we're going to have a graph that is looking down like this. Now we can do that quickly on a rough sketch, then we'll relate that to verify what they're saying. Now if we have y equals to let's say 2x squared, 2x squared. Now having this graph, so of course we'll need to close the points here. And then of course we'll have 1, 2. Then here we have minus 1 and then minus 2. Let's do that. Now if we need to plot this graph, okay, we'll substitute the kind of table method of saying having x and y. And then of course we can have three values, 0, minus 1 and 1. Then we'll get the output. But if you put minus 1 in here, of course we'll have 2 into minus 1 squared. So the answer will be 2. So if you put minus 1, you'll have an answer of 2 here. Right, then now if we have 0, then we also have 0 here. And now if we have the value of 1, 2 into 1 squared, then the answer will be 2. So 1 and 2 will be here. Now if we join this, now we're going to have a simple graph like this. Sorry for that. Now we're going to have a simple graph like this. Here there will be the turning point, then from there it goes like this. So can you see that if a is positive, then it means the graph will concave up like that. Then now suppose the y is negative, minus 2x squared. So let's use this curve, minus 2x squared. So now this will mean, okay, now let's put the values. So minus, sorry for that. So now if we're here, we'll say, okay, now we can use the kind of the same table, x and y table, and then we'll have our three values, 0, minus 1 and 1. Now of course if you put minus 1 in here, so the answer will remain minus 2. So if you put 0, then we have 0 here. If you put 1, the answer will remain minus 2. So now if you plot the graph, at 0 and 0 will be here, and then minus 1 it goes with minus 2 will meet here, then 1 and minus 2 will meet here. So this will be the turning point. Now on this turning point, if you draw the graph, it will be something like this, something like this. So can you see that minus 2x squared? So can you see that for value of a being negative, which is less than 0, then the graph is going to come set to concave down. That will be happening on the shape of a. It's still giving us the shape in the most cases. Then now, looking at this equation, the same will happen here. So meaning that if we still have this part, then it means a is still responsible or accountable for these shapes. And now, looking at the equation, there is an extent here. So what is this q? Now q here, it shows the shifting of graph. Shifting of graph. This will be shifting of graph vertical. So if our graph is shifting vertically, then it means vertically is either up or down. Now the graph was from 0 and 0. Now if we need to say plus q, then it means the graph will shift up. So for plus, then if this is minus, then the graph will shift down. Looking at the graph here. So it means having this graph here, the value of a is greater than 0, is positive. Then if the graph is positive, then what else can we say about this? Now here, it means there will be a turning point. This will be the value of q. Then that q shows that it's a negative, because on that Cartesian plane, having the value, the y underneath is going to be a negative number. So it means the graph has shifted down units by q. So a certain unit of q, then it's going down. So let's take the same graphs here, this ones, and see what we can have. So now, let's just quickly do another one for the shifting. So having Cartesian plane, having 1, 2, minus 1, minus 2, 1, and 2, and then minus 1, and minus 2. Right, then now let's say we want to plot y equals to maybe x squared plus 1 and see what we have. So okay, now if we do the part of our table again, which is x and y, and then 0, minus 1, and 1. Right, so let's check. So if you put minus 1 here, then we're going to have an answer of 2. Then if you put 1 here, I mean 0, then we're going to have an answer of 1. And if you put 1, then we're giving answer of 2. So this will be 2. Now let's plot the graph. So if you put the 0, we have 1. So we'll pass through this point. Then if you put 1, then it's going to have output value of 2 here. And then if you put minus 1, it's going to have a output value of this one. So if you look at this one, so this will be the shape of the graph here, like this. So now can you see that adding this will be q, and this is plus 1. So it means the graph will go up 1 unit, or by the value of q that is being put there. So that's why the graph is being shifted up. So this is the graph of x squared plus 1. So can you see the effect of q? So if it's negative, it means the graph will shift down, and then we'll have that case. So now out of this one, they're saying again, if the graph is shifting that way, then it means this Q will also be the y-intercept. So y-intercept meaning that's where the graph will cut the y-axis. So this is y-axis, x-axis. So this having Q is where the graph will cut the line of y-axis. And then it's also called the maximum or the minimum value. So when do we say maximum or the minimum? Now the graph, the value of y here for this graph will start from 1. So meaning the value of this graph will start from 1 going up. But going down there is no graph because the graph showing that is moving up infinitely. So it means the graph will start from this one. So if starting from positive 1 and it's concave up, so it means this will be the minimum value here. So this will be the minimum. This will be the minimum value in this case. So now, if the graph is like this, in this case of concaving down, so it means the graph will start from 0 and it's going down. So if it's going down like this, then this will be the maximum. This will serve as the maximum value here at the value of Q. So it will be the maximum because the graph go from 0 is moving down in that case. Right, that's the minimum and the maximum defined by that. So axis of symmetry. Now the axis of symmetry is the line that is dividing this graph into two equal parts. So meaning if we have a line like this, if we have a line like this, oh, we need a ruler here. So meaning if we have a line like this, the line is going to cut the x-axis, then yeah, at 0 in that case. So it means the graph here, the line of this graph will be x equals to 0. So meaning that if we have a line that is going like this and it's going to pass through the center of y-axis, then there will be y equals to a certain number there, or y equals to 0 in that case. So or maybe y will be equals to maybe q in that case. So then what I'm saying is that because the line is going to cut through this part, so this is x equals to 0 because it's cutting the graph into two equal parts at x equals to 0 in that case. So meaning two equal parts means the distance from here up until here is the same. So meaning the distance from this point to this point, then they are also equal. The distance from this point to this point, they are also equal. So that's what we mean by the axis or the axis of symmetry. So that's what we need to have. Let's divide the graph into two equal parts. So we'll elaborate more on the other parts. Then it's fine. What is the other part? So we have the axis of symmetry. Now they'll say the equation. This is also called the equation. This is the equation. This is the equation of the axis of symmetry. Now when it comes to the domain are the x values where the graph does exist. So meaning that at any point this graph is going that way far to the right infinitely, so, and this is also going to the left infinitely. So it means for every point that I touch here going up, I must touch the graph. So if I touch the graph, then it means those values are, they does exist in that case. So meaning that the x will take any real number that will be on the Cartesian plane. So that's why we say an x is an element of real numbers. Then let's go for the range. So for the range, we'll say if the graph is like this, of course, for this one, we'll say y is greater or equals to q, the value of q. So maybe let's use this one here. So if you check out this one, if we check out this one, let's try this one. So if you check out this one, we'll say y is greater or equals to 1, because now the value of q is 1 here. Then now if it's 1, it means now the graph will start from 1 going up there. Then now if the graph is concave down like this one, then that will say y is less or equals to, what is the value of q? In that case will be 0. So that will be the range of the graph. So that's why here they're specifying if a is greater than 0 is this part. That's why I say y is greater or equals to from the minimum going up. Then this one is say from the kind of the maximum going down. So that's why I say less or equals to in that case. Again, there is what we call the turning points. Now on the turning points here, what we have, the turning point, okay, we'll have them here. That's why they say the turning point here is 0 and the value of y, the value of q in that case, that will be part of the turning point. So it means the turning points of this graph is 0 and 1, and therefore these two graphs is 0 and 0. So this is what we have for this part. So that's it about this grade 10 parabola, but it can come also in grade 11 and 12. So let's be careful. Now on the next video, of course, we'll check the shifting of both x and y, because here only looking at the shift of y value here. So in the next video we'll check both shift up or down, left or right. So that will be the end of the first part.